because we're going to start using derivatives to tell us what's happening to the graph. But I think it's I think it's easy for students to grasp this lesson. So a little bit of theory here. So our objectives for today are to determine when intervals are increasing or decreasing and apply the first derivative test, which tells me relative extrema. All right, so our academic standards. So let's define what increasing function means. So the definition, which you do not need to know, but in this section you will learn how derivatives can be used to classify relative extrema. So when I say relative extrema, you're thinking peaks and valleys, hills and valleys, okay? They're not the absolute, they're just as we move along our graph, either a peak or a little valley. All right? Let's make sure we understand the formal definition of what increasing means. You don't have to know it, but I want you to understand it. A function f is increasing when I pick one number of x and then something to the right of it, x of 2. So x of 1 is less than x of 2. Does that make sense? Like if that's 1, that's 2. And when I plug into the function, the output of the first value is less than the output of the second value. So what I'm saying is, if I'm going along a line, this value is less than this value, then my function is increasing. Whereas it's decreasing when this function is less than this one, and the value of the first one's bigger than the second one, so it'd be like this. Here's the first one, here's the second one. That's a decreasing function. Is everybody with me on that? Okay? So let's look at it from a visual perspective. So right here, the graph from negative infinity to, we're calling this x equals a. So follow me here. The graph is decreasing. Then we call this the constant, because these values are remaining the same. And now my function is increasing. Y'all follow me? Now look at this. I now am beginning to understand the derivative. If I drew a bunch of tangent lines, and we've done this a little bit already. If we drew a bunch of tangent lines, what's the slope of every one of those tangent lines? Positive or negative? Negative. And if I drew tangent line here, every tangent line is what? 0. So that's why it's a constant. And if I drew the slope of the tangent lines here, these are all positive. That means this. If the derivative is less than 0, my original function was decreasing. If the derivative is equal to 0, it's a constant. And if my derivative is greater than 0, my function is increasing. Okay? We've talked about that a little bit, but we're going to use that to help us find relative max and minimums. And that's using the first derivative test. Questions over this slide? Okay. So, testing for increasing and decreasing functions. All right? Let f be a function that's continuous on the closed and differentiable in the open. And you can determine this. If the derivative is greater than 0, which means what? The derivative is positive. The original function is increasing. I do think this is necessary for you to write down. This is how you test for increasing and decreasing functions. If the derivative is positive, the function is increasing. If the derivative is negative, the function is decreasing. And if the derivative is equal to 0, then the original function is a constant. So I'll let you guys write that down. Three x squared minus 3x, right? And now let's set that derivative equal to 0. Let's factor out a 3x, and I'm left with x minus 1 equals 0. So again, critical numbers are where the derivative is equal to 0, where the derivative is undefined. There are no undefined y because the derivative doesn't have a denominator. Doesn't have a variable in the denominator. So We're going to set 3x equal to 0, so x equals 0. And we're going to set x equals 1. Y'all with me on that? Now, this is what we do. And you can make it very simple. Okay, you're going to look at intervals. And because I give you no boundaries, we're going to go from negative infinity to 0 to the first critical number. We're going to go from 0 to 1, and we're going to go from 1 to infinity. Y'all follow me on that? I'm going to set up a real quick little table. Okay? And I want you to just make a little table with me. Okay? And I'm going to put f prime of x here, and I'm going to put f of x here. And you're going to hear me say, pick test points. Pick test points. So what's a number between negative infinity and 0? Negative 1. So let's put the test point right above it. Negative 1. What's a test point that we should... So these are my test points. What's a number between 0 and 1? That's easy to work with. 1/2. And what's a number that's easy to work with between 1 and infinity? 2. Those are my test points. So everybody follow me. Test point number 1, negative 1. I'm going to plug it into the... So I'm going to find f prime of negative 1. And all I want to know is it positive or negative? Y'all follow me? All I want to know. So follow my cursor here. Plug right here's my derivative. I think it's easiest to plug it in the factored. So that 3 times negative 1 would be negative 3 times negative 2. What's negative times negative? Positive. Everybody put positive. If the derivative is positive, the original function is increasing. Cool? All right. Pick 1/2. That would be positive times negative. So f prime of 1/2, positive or negative, guys? Negative. Does everybody understand how I get the negative? I plug it right in here to the factor derivative. And if it's negative, that tells me the original function is decreasing. And now if we plug in 2, I get positive times positive. F prime of 2 is positive, which tells me the original function is increasing. So this tells me even more. Look at this. I'm increasing. I get to a critical number 0. I get to the critical number of what? 0 from negative infinity to 0. So, and what it goes from increasing to decreasing. That means 0 is where a relative maximum occurs. It increases, decreases. Also, then look at this. I'm decreasing. I get to the value of 1. At 1, I have, and then I start increasing, so I have a relative minimum at 1. I don't know what it is, but I know it's occurring there. That's what the first derivative test allows us to find. Okay? Now I'm going to hit next on my screen. This is going to disappear. So is everybody okay with what we just said there? Maybe let's write this down. There was a relative max occurring here at 0, and there's a relative minimum occurring at 1. Now, 0 comma some value, I plug it back in the original. That would be 0 comma 0. Okay? And if I plugged in 1 into the original function, that would be 1 minus 3/2. 1 minus 1.5 would be 1 comma, is that negative 1/2? Everybody cool with it, what we're doing? Question? Because I'm going to go next slide. And then this is all going to go away. Okay? This is all what we just did. And then they did the same thing. And then there's a visual that shows it to us. Look, we said there was a relative maximum at 0, 0. And we said there's a relative minimum at 1 comma negative 1/2. So these are the guidelines about how to determine increasing and decreasing functions. I want to throw a vocab word at you guys. A function is strictly monotonic on an interval when it's always either increasing or always decreasing. So that's a vocab word that we probably, strictly monotonic means it's always increasing or always decreasing. Look at this one. I do have a critical number here at 0. Does everybody see, look up here on my cursor, does everybody see how that tangent line right there is 0? But before it, it's what? Increasing. 0, and then it continues to what? Increase. That is not a relative max or min. It's actually called a point of inflection that we'll learn next time. Okay? So, we did the first derivative test. That's going through it here. Let's do another one. So, find the relative extrema of the function 1/2 x minus sine of x. And we're only going to look at the interval from 0 to 2 pi. Everybody clear on that? Okay. So what we're going to do is we're going to find critical numbers. Let's find f prime of x would be, derivative of 1/2 x would be 1/2 minus the derivative of sine of x would be cosine x. Everybody agree? We're going to set our derivative equal to 0. We're finding critical numbers. Again, let me ask you the question. Critical numbers also occur where the derivative is undefined, but I have no variable in the denominator, so we're finding just 0. And then you add the cosine of x, and then let me ask you this question. When does, think unit circle, when do I have the cosine equal to 1/2 at pi over 3 or pi over 6? I heard both.
Pi over 3.
Let's see. Here, ready? You don't have your unit circle memorized. I think this. 1, 2, square root of 3. That's a 60-degree angle. What's a 60-degree angle? Pi over 3. Okay? So we have it pi over 3, but I think it occurs somewhere again, doesn't it? In the interval from 0 to 2 pi. A, smart, trig. We're going to have a positive cosine in quadrant 4. That's what? What is it? It would be 5 pi over 3, wouldn't it? It would be 5 pi over 3. Okay? So those are our two critical numbers. Everybody clear with that? Now, from here, let's set up that little interval. We're starting from 0 to pi over 3. We're going to then go from pi over 3 to our other critical number, 5 pi over 3. And then we have an interval from 5 pi over 3 to 2 pi. Okay? Little bit more complicated because you got to think of numbers in the unit circle in that interval. Y'all follow me? And all I want to know is this is f prime of x, and then that's going to tell me what f of x is doing. Okay, everybody have this set up? I'm going to go to my next slide. I'm assuming they're going to have a table here for me. Okay? Good? So now, okay, here's our table. Now look, they listed the test values here. So put pi over 4 above yours. Put pi, and put 7 pi over 4. And all I want to know is the sine. What is f prime of pi over 4? And and when I plug that in, I get a negative value, which I can conclude that it's decreasing. I get a positive value, increasing. I get a negative value, decreasing. Fill that in. Here we go. I'm decreasing to increasing. Therefore, I have a relative minimum where? At pi over 3. I'm increasing to decreasing. Therefore, I have a relative maximum at 5 pi over 3. Everybody clear of that? Now, if I wanted the output, like where's the relative max at? 5 pi over 3, comma, where do I plug that 5 pi over 3 at? Into the original function. So look at my graph here. Here's my relative minimum. Here's my relative maximum. Does that make sense, guys? Okay. You have a 3.3 WebAssign that's due on Wednesday. Okay. Now I tell you what, I'll make that due on. It's due on Wednesday. It's due on Wednesday. Well, if you didn't get the other one done, it was just those couple problems. Yes.